Welcome again to Let's Talk Advanced Chemistry. Let's Talk Chemistry 2 with Pastor Dan. We're going to look at Hess's Law. And sometimes I move this around. Sometimes I do another concept first. But I'm going to go with this first because this can be a bit challenging. This will give you more time to prep with it, work with it, and see how it works, and we'll do more practice that way. All right, Hess's Law is defined as the energy of a reaction that can be determined using the sum of the energies of formations. Now, what exactly is a formation reaction? So a synthesis reaction from the base elements that forms exactly 1 mole of a substance. Now you'll notice that we have to identify the states of matter. So sodium is a solid, chlorine is a gas, sodium chloride, NaCl, is a solid, and you'll notice this is 1 mole. So this chlorine, to get it balanced, has to be a half a mole. All right, let's do other ones here. Let's do water. So if water liquid, it's going to be H2 and O2. I've got 2 hydrogens. I've got 2 hydrogens. I've got 2 oxygens. I've got 1 oxygen. Usually I put a 2 there, but I can't balance that way because it has to be 1 mole. So we're going to put a half mole in front of the O2. All right, let's try calcium chloride. Well, the elements involved with that are calcium solid, carbon solid, and oxygen. Now I have 1 calcium, 1 calcium, 1 carbon, 1 carbon, 2 carbons and 3 carbons. Again, I can't put a 3 and 2, so therefore I'm going to have to put 3 halves to get it in. Now I use that with something called Appendix C, and I'm going to pull that up right here so you can see that. It's a long chart. I will try to put that in the notes so that way anyone can grab them and use them as they need that. All right? All righty. So the values from that chart, we have negative 410.9 kilojoules per mole. Remember, negative means it's exothermic because they're giving off heat. For water, it's negative 285.83 kilojoules per mole. For calcium chloride, it's negative 1,207.2 kilojoules per mole. All right, now, knowing that, we're going to use that for a given reaction. Now, we have 3 compounds here. We have C2H4 ethene. We have CO2, carbon dioxide, and H2O, water, and water here is a liquid state. So there's 3 compounds that we have to generate. Balancing it up, we put a 3 in front of the oxygen, a 2 in front of the carbon dioxide, 2 in front of the water. All right, from our formation reactions, we have 2C plus 2H2 is C2H4, and that reaction is at 552.30 kilojoules per mole. It's positive. It's endothermic. It's going to get cold to form it. It's going to require energy to form it. All right. For the other 2 then, we have carbon plus oxygen gives us carbon dioxide, negative 393.5 kilojoules per mole, and H plus 1/2 O2 yields H2O in a liquid form that's negative 285.83 kilojoules per mole. Now, look at the reaction here. C2H4 is on the reactant side. Over here, it's on the products. So we're going to have to flip that reaction. When we flip that, instead of being a positive 52.30, it's going to be a negative because the reaction is going in reverse. All right, the number of moles are the same, so we're good there. All right, for carbon dioxide is a product. Carbon dioxide is a product, so we can write it as is where is. But you'll notice this is 2, so we take our value here, and we're going to multiply it by 2. If we take negative 393.5 times 2, we get negative 787. And we're not going to worry about sig figs here. I can hear a little cheering going on. Yay! We're just going to take the values as they are and record them as they are. For water then, again, water is the same. It's on the product side. It's on the product side. And then we're going to take our value and multiply it by 2. So we're going to take our value here, multiply it by 2. And we get negative 571.66. Now, what we're going to do is check this all out. Anything should cross out. So my hydrogens cross out. They're on both sides of the reaction. My carbons cross out. We end up with oxygens remaining, but 2 plus 1 is 3. So we bring everything down. The reaction is the same as it is up there. So we're going to add these values up. Negative 52.30 kilojoules per mole, minus 787 kilojoules per mole, minus 571.66 kilojoules per mole, is negative 1,710.96 kilojoules. We're not going to worry about it.
410.
Figures. We're just going to put everything as we see in the calculator. Make it easier since we're dealing with numbers off a sheet. All right, let's take another problem. That's our answer. Let's take another problem. Find the enthalpy reaction of HCl aqueous, means it's a solution, plus Na2CO3 solid, that's sodium carbonate. Yields to give us salt, NaCl, sodium chloride, plus carbon dioxide, plus water. Going to balance it up, put a 2 there, a 2 in front of the NaCl. All right, so we're going to have 5 compounds we have to identify here. HCl, aqueous, balancing it up, half H2 plus half Cl2. HCl, we're getting negative 167.2 from appendix C. The other one's there for sodium carbonate. The value is negative 1,130.9. For sodium chloride, it's negative 407.1. Carbon dioxide, negative 393.5. And for water, again, it's liquid, so it's negative 285.83. I didn't put the kilojoules per mole there. We assume they're there. All right, and again, if it was gas, it'd be a different value. All right, for the first one, for HCl, we're going to flip it and multiply by 2. So we're going to flip the negative and make it positive, and then multiply it by 2. So we get positive 334.4 kilojoules per mole. For sodium carbonate, we're just going to flip it. We don't have to multiply it. So the number just gets flipped. Instead of negative 1,130.9, it's positive 1,130.9. For sodium carbonate, sodium chloride rather, we're going to multiply it by 2, put it down as is. Where's the same side as a reaction? So we take our value and multiply by 2. We get negative 814.2. Carbon dioxide, we keep it as is, where is, and so the sign is, for the enthalpy of formation is still the same, negative 393.5, and water will also be the same. Start crossing everything out. Hydrogens cross out, chlorines cross out, sodiums cross out, carbons cross out, and my waters, 3/2 and 1 is 3/2, they all cross out. So we end up with negative 28.25 kilojoules per mole. Again, our answer. So it's exothermic. That's a reaction if we run the reaction through. All right, let's do one more type of problem that we can do. Now, this is another way we can do this problem. We can determine the enthalpy of formation. We can find it. If you go back in Appendix C, you'll see there is no aluminum fluoride listed. And this is all from the textbook, Brown-Lemay AP Chemistry. That's where I got that Appendix C from. Formation of aluminum chloride, if the enthalpy of formation. So I'm going to give the reaction, and you do see aluminum chloride in there, so we can work from there. So what we know aluminum chloride from appendix C is negative 705.6. We don't know aluminum chloride. We know aluminum fluoride in the reaction, gives us that reaction. So balance up the reaction first, okay? And we'll put that reaction down and have its value negative 329.8. Of course, that's kilojoules per mole. Okay, if we take and we want to get rid of aluminum chloride, we're going to put aluminum chloride on the opposite side from it so that it crosses out. And we're going to have to multiply it by 2. So we multiply that value by 2. We get it negative 1,411.2. When we do that, our aluminum chlorides cross out and our chlorines cross out. Bring everything else down, we get 2Al solid plus 3F2 gas gives us 2AlF3 solid, but we only want 1 mole for formation. So we're going to take that value that we get, we're going to divide it by 2. So we have to divide the answer we get by 2. So the answer is negative 870.5 kilojoules per mole, and that's my answer. All right. Take and do one on your own here. I'm just going to show you the answer. So find the enthalpy of formation.
Okay, so look at Appendix C here. I'm going to pull it up, pause it, use it for the values. Calcium oxide, calcium's over here, calcium oxide's there, barium oxide, oh, it's not, is it there? Oh, shoot. They didn't include it. I'll give it to you. calcium chloride. Calcium chloride is right there. All right, so we'll just work through it then.
Barium chloride, so this is the same kind of process. Pause the video, give it a shot for the reaction barium oxide with calcium chloride. All right, so give it a shot here. All right, here's the answers. So barium chloride is what we're looking for. Barium oxide is negative 553.5. Calcium chloride is negative 795.8. Calcium oxide is negative 635.5. The reaction is negative 141.2. We're going to write calcium chloride as is, where is. So my calcium chloride's cross out. Barium oxide, we're going to write it as is, where is. So my barium oxide's cross out. We're going to flip barium oxides. So all that we're left with then is barium plus chlorine is barium chloride. Answer is negative 855 kilojoules per mole. All right, that's it. Hopefully not too bad. We're going to practice these twice. So you're going to have 2 days of practice. All right, not too bad. Hopefully take care. God bless. Bye.